Well, actually, no, it's not. I've got a typo there. Oh, yes, at that distance, but it would appear to be twice the size of the Moon. Now, number 7 is Triton. And Triton is one of Neptune's moons. It's the largest moon of Neptune's. And when you compare it to our moon, it's actually not much smaller. It's pretty close to the same size. And it's interesting, firstly because it orbits Neptune backwards. Most of the moons orbit the planet the same way the planet goes around, like our moon. The Earth turns this way, the moon turns that way. In the case of Neptune, Neptune turns this way, Triton goes back the other way. And it doesn't just go in the line, it actually comes around and goes this way, the opposite way. So it's in at a high angle and it's going backwards. So they think this has actually also come from the Kuiper Belt. So it's like Pluto, very similar to Pluto. They think it's come from the same part of the solar system. And the gravity from Neptune has captured it, pulled it into this orbit. And they've measured the orbit and it's slightly decaying, so it's getting closer and closer to the planet. In about 3.6 billion years, they think it's going to get so close that the gravity from Neptune will rip it to pieces and create a huge ring system around Neptune. Yep?
How do you know that it's going on the diagonal? Because if you're looking at a different angle, it's straight.
Well, they know which way the planet rotates. So like if the planet's rotating here, then most of the moons orbit what they call the same plane. So you put like a piece of paper through the middle of it, and the moon and all the planets turn and the moons go in the same line. This one, it actually goes around like this.
It will turn that way.
It's also going backwards. All the other moons go the same way as the planet's rotating. So they all go together. This particular one goes back the other way, and it goes up and over instead of around. So in a telescope, you can actually see Triton if you've got a fairly big telescope, and you would notice that it's going in the opposite way. Probably bigger than that. You can see Neptune easily in something like that, but you'd need quite a large telescope to see Triton clearly. A lot of the stuff that we know about Neptune was from Voyager 2, which visited Neptune and Uranus around 1989. They're currently way past Pluto's orbit now. And a lot of the things that we know about Triton, we know purely from that probe. There's been no other probes go out to those planets since, and there's no plans at the moment to send anything else out there either. One thing they noticed on the surface, it has very few craters. First thing you notice when you look at the moon, it's full of craters. They counted the surface of Triton and it's only got 179 craters. Mars has got 50,000 or more. This has only got 179. So something, because it's still getting impacted like everything else, something is erasing all of these impacts as they form and gets rid of them. They think that's because the surface is largely ice and something's causing the ice to melt. And as it melts, like on Ganymede, it erases all the craters. So you get an impact and a few million years later, it's gone. So it's being reset all the time. Another part of it, the surface, they've called it a cantaloupe texture because it looks very much like a cantaloupe. If you've ever seen one, it has this rough textured finish. To give you an idea of scale, most of these little circular things here, they're about 30 kilometres across. So basically from about halfway from here to Melbourne. So where we're here, Melbourne would be about there in size. So about half that sort of distance in diameter. And all these little lumpy bits, I think, is just ice. There's warmer ice on the bottom, and it's like warm air rises. Warm ice also rises, and the cold ice moves to the side. That's why glaciers move. Not because they're warmer, but because of the gravity, but ice moves, even when it's very, very cold. And they think this warmer ice is just coming up underneath the colder ice on the surface, and it's creating this texture. Another thing they noticed was all these black marks everywhere. And they're also able to capture on the edge of the planet, they could see some of these plumes like a geyser shooting material up into space. And what these appear to be, are small holes in the surface, and nitrogen that's below the surface gets warmed and then punches a hole through the surface and comes up and shoots this nitrogen into the air. And it takes little bits of dirt and stuff with it as it goes through these holes in the surface. And as it gets distributed, you can see here the geysers line up through here, or geyser, and the material has spread out over the surface of the moon. You can see lots of them there. It has an atmosphere that's mainly nitrogen, and it goes nearly 1,000 kilometres high, so it's much, much higher than our atmosphere, but very, very thin. Our atmosphere is 70,000 times denser. But you can see in this picture, this is a very thin cloud of nitrogen. So nitrogen ice or something like that. If you were standing on the surface of Triton, you would see Neptune, and no matter where you stood, it would not move. It would appear to be stationary, but it would be 9 times bigger than our moon. So to blot out Neptune from Triton's surface, you would need both hands to block the whole planet out because it's so huge. But it would be in the same spot every day. It would never move. Hyperion is my number 6. This is another moon from Saturn. The interesting thing about Hyperion is it looks like a sponge. Just like a kitchen sponge. It's full of all these holes. It's also interesting, it's the only moon that just tumbles around its planet. Most of the other moons have a particular spin. They rotate. They're predictable. We can predict what parts of the moon are going to be visible at any particular time. But this one just rotates chaotically. There seems to be nothing that determines what face faces what at what time, and it's just tumbling around Saturn all the time. It's mainly ice and rock. And if we look carefully, down the bottom of these little holes is all black material, and they think this black material is also coming from little Phoebe. So some of the material that the apertus doesn't pick up, this picks it up as well if it's gone past the apertus. And it gets stuck in the bottom of these little holes. And then because they're covered in this black material, they get a little bit warmer. And so the ice melts a little bit more, and so they get deeper. And as they get deeper, they get more black material, and they get warmer, and they melt. And that's, they think, why it's got this weird sort of shape. So where a little bit of black material starts to deposit, it just takes off. And it gets blacker and blacker and deeper and warmer and picks up more and gets deeper. And that's why it's created that sort of a surface.
Like the one that you can jump off the edge and end up...
Yes, it's the same material. I think
and
it's...
can you like jump off of that cliff and do the same thing?
Oh, it doesn't have a crater anywhere near as big as that. Yeah. But it's the same material that's on Phoebe. My next one is number 5, Io, which orbits Jupiter. It's the only moon that doesn't look anything like a moon. It looks more like a pizza. Right? It's the only moon that looks like lunch. It's covered in lots of volcanoes. The yellow coloration is because there's a lot of sulphur. The volcanoes are active, so it fires only sulphur dioxide and materials like that up into space. And molten sulphur, and also molten rocks. It has 400 volcanoes, and they're erupting all the time. It's the most geologically active thing we know. More volcanoes than on the Earth.
So if
many
you
more.
land on there, you would die like in a millisecond.
No,
it's
you'll
cold.
die before you even get
Yes, you die before you got there. Now you can see in this video, this is a time lapse, and this is one of those volcanoes. It's spewing this mainly sulphur dioxide out into space. and most of it, of course, settles back onto the moon, but some of it actually escapes and it orbits around Jupiter. And some of it actually ends up on the next moon out, Europa, which is also one of my top moons. You can see here, there's a plume of material that's coming out from a volcano that just happens to be on the edge of the field of view. You can see flows of lava, how they've poured down a slope here somewhere and then they've suddenly stopped flowing because the lava has frozen. Right, it's ceased to be molten. You can see a number of places where it's flowed and then it's just, the flow has eased off as the lava has cooled and then it's stopped. And then maybe another lava flow has come past at another time. But it's interesting that the temperature on the surface is 180 degrees below zero. So where does all this heat come from? How can you get lava at 180 degrees below zero? This is much, much colder than the Antarctic on the coldest day you could imagine. Yeah.
Could it come from Jupiter itself?
Yes. It's what they... It's far too small to keep the heat, like the Earth keeps heat, and that's why we have volcanoes. It's far too small. Actually, I should drop that out. It's only that big. It's about the same size as our moon. It's too small to keep the heat. It should have been cold by now. If we look, and we exaggerate it quite a lot, if we look at the orbit of Io around Jupiter, it's elliptical again, right? So it's much, much closer at one point than it is at the other. This is highly exaggerated though. So as Io comes close to Jupiter, it's subject to a lot more gravity than when it's further away. So it gets maximum pull when it's close, and it gets a lot less gravity as it pulls away. So you imagine, every time it goes around, the gravity is changing. And what actually happens, it squishes and squashes the whole moon 100 metres in size every time it goes around. So it's like a big organ grinder. It's got a whole moon and it's squashing and expanding this moon every 1.7 days. If you do that, it creates a lot of energy. This is what they call tidal heating. So the effects, same sort of thing with the tides with the moon, causing the tides here in the water. In this case, it actually causes tides in the moon itself. It actually raises the tide in the rock that makes up the moon. So when it's close, it actually stretches the moon out 100 metres, and when it's further away, the moon relaxes back 100 metres in diameter. The total amount of energy that they've calculated this produces is 1 million megawatts, which is 20 times more energy than the whole of the Earth can generate. So an incredible amount of energy. And this energy is being pumped into Io, and that's what's melting all this material. So you've got 20 times more electricity than what we can generate is melting this moon. Yeah?
Ever seen what I'm saying?
Oh, nowhere near. It is slightly elliptical, but it probably wouldn't raise more than a few millimetres. Yeah. Anything that's elliptical, it will create a slight distortion, but because Jupiter is so massive, and this moon is actually a similar distance to our moon, it's quite a large effect. Yes.